We left off. Okay, here we go. Here's the recording. So this is Badiou's being an event reading group. We're going over section 1, which we started last session. We did sections, meditations 1 to 4. So section 1 has 6 meditations. And in the first session, I just gave a general verbal outline of the first 4 meditations. So I don't expect you guys to actually know what they were about, but that's where we were. So that's where we kind of left off, just so we can orient ourselves. In this session, I'm gonna actually show you the sort of mathematical guts behind what was happening in meditations 1 to 4, so that you know what I was talking about, all of that gibberish about the void as the proper name of being, the non-being of the one, the multiplicity of being, and so on. And we're also going to go over meditations 5 and 6, which are the philosophical conclusions of what we went over last time. So by the end here, I'm hoping that we have a good grasp of what is required as a sort of prerequisite for anybody going to read section 1 of being an event, right? Because I don't expect you guys to have read section 1 of being an event. But after this session, and it would be slightly better if you were there in the first session as well, you would actually be able to go into being an event, the first section, and not be like overwhelmed. So that's my goal. Okay, so just checking. Can everybody see my whiteboard? I'm hoping that everybody can see the whiteboard, where we've just got the title, and we're going to start off by very quickly going over our first session. So, what was the first session about? Meditation 1. Meditation 1, we had the affirmation of being as multiple. Being is multiple, and the negation of the one. The one is not. Okay, that's where it was. And meditation 1 is not clear about exactly what that means, so don't worry if you don't know. It is simply an axiomatic state of affairs. Axioms in maths is where any system of mathematics has to start. So in maths, things are not sort of proven to you immediately in an empirical way. It's not like you like go out in the world and you like find the atoms of mathematics. No, what we call these things are axioms, and axioms are essentially where you have to affirm something that feels intuitively like it should make sense, but there is no mathematical proof of it because there's no mathematics before that axiom, right? The axiom is what starts the mathematics, and then you've got mathematical proofs of stuff that comes after the axioms, but not of the axioms themselves. So the axiomatic assertion in being an event is that the one is not. That's the axiomatic assertion, and it's a really nice assertion because it's a negation. It's not an existence statement. An existence statement would be like there exists a number 1, or there exists a geometrical space with 3 dimensions, right? Existence statements are kind of hard to prove, like Russell's teapot. If I said there's a teapot in the orbit of Saturn and in between the moons and somewhere in the rings, go find it. That's kind of hard to do, right? An existence proof is not something that you want to base everything that you start off with. And in maths, it's actually common to have an existence as an axiom. But the most important one for Badiou is actually the negation of something. As in, there is no such teapot. There is no one that you can find anywhere in what we're going to follow. So that was meditation 1. Of course, there's a lot more to these. So when you're going to read them, you're going to find this stuff. You're going to be surprised by how much is left out here. But this is the key. This is the key that you sort of need to like, if you get lost in the text, this is going to help you. So in meditation 2, we had structure. Structure. and situation. So what is a situation? Situation is any presented multiple. Right. A situation is any presented multiple or multiplicity. The thing about a situation is it can be anything. Anything is a situation and everything is a situation. However, there's a very important difference between anything and everything. Because if I said everything is a situation, which I did, but you'll see that I'll contradict myself a few times here and there. This is because we're dealing with ontology, which is a philosophically slightly contradictory thing. If I said everything is a situation, then I'm totalizing the multiplicity of being under the one, as in there is an everything, there is one everything, right? But that's what Badiou says the one is not. So there is no one everything. There may be an everything, but it would be part of a multiplicity that makes up an everything, right? So whenever you are presented with something or anything at all, then that thing would be a situation. So the fun part about this thing is it's kind of empirical. It's like if something comes along, right? You're presented with something. If you find a teapot, whatever, that's a situation. If you want to be given everything all at once, that's not a situation because that never happens, right? Structure is what happens when you perceive a situation. What does that mean? It is because everything is multiple that it only appears as structured. So structure is the count as one operating in a situation. Right. So situation is this sort of like anything could be a situation. And a structure is when that anything appears by itself as opposed to unseparated from the infinity of possibilities that anything else can be a structure. So anything that sort of appears is a thing because phenomenologically speaking, not ontologically. If you phenomenologically think of a thing in your brain, it appears as one thing. Like you're almost never able to think about two things at once. There's no such thing as like multitasking psychologically. I say pink elephant, and there's a unity of the pink elephant. That's a structure, right? There's a multiplicity of pink elephants that you could have imagined, like some infinitude of different images of pink elephants that exist out there in a virtual, whatever situations. But when I said pink elephant, it was the structured count as one, which picked out one of them and just presented it to you. That's what structure is. That is meditation too. What's important about meditation too is that situation and structure split multiplicity into two. So multiplicity is all the way down. So ontology is made up of multiplicities. If you ask what exists, it's multiplicities. And for Badiou, later in the third book, towards the beginning of the third book, you find out that he meant infinities. Multiplicities, infinities, what exists is some sort of infinities. That's what he wants to say. But multiplicities don't have to be infinite. You can have finite multiplicities. Those are just included in the infinity of possibilities. The thing about multiplicity is it can be either consistent or inconsistent. So we're going to split that into consistent and inconsistent. Consistent, inconsistent. So what is a consistent multiplicity? It's the multiple after the count as one So count as one is important. And what is inconsistent, it's the multiple before the count as one. I will break that down now. Count as one is the operation that exists. There is no one, there is no thing that is a one, but there is a process that creates unities or onenesses out there. And that's what we call the count as one, right? So there is no one thing which is the one, but there are a multiplicity of processes which create unities among situations and structure them into consistent multiplicities. So when the count as one operation finds a situation being an inconsistent multiplicity, it then structures it into a consistent multiplicity. That's the resulting structure. Why is this important? Is because we primarily go back to Lacan a lot, and Lacan is instrumental for Badiou. What is the inconsistent multiplicity, or otherwise the pre-count as one situation? It is the real of any situation. And that real is Lacanian. That's the Lacanian real. Right. The inconsistent multiplicity is the Lacanian real of any situation. What is the consistent multiplicity? It's the multiplicity after the count. After the count. And it is what the Lacanian symbolic produces from the real. There we go. So when the symbols impose themselves onto the inconsistent multiplicity, you create structure, or the symbolic order produces structure out of the real. That in Badiou is this interplay between consistent and inconsistent multiplicities. Right. We're gonna add a page because we're gonna go on to meditation 3. Meditation 3, there's a few important things that happen in it, but the one that I want to show is Russell's paradox. And I'm not gonna write it out just because we're just doing a summary of what we did last time. And that was actually something that I wrote out in last time's, because I couldn't use the whiteboard. And I managed to actually write down this one thing. But what does it mean? Russell's paradox for Badiou is a proof that language cannot totalize the multiple. That's what Badiou says he interprets Russell's paradox to do. It is language cannot totalize the multiple, is anything that is inside the multiple cannot totalize the multiple itself. That's a very simple idea which governs Badiou's central decision to say that the one is not. That's because any totalization of the multiple under the one creates inconsistencies or paradoxes which just negate it. There is no such thing as a paradoxical being or God, right? The one is not. God is not. That's either God in the Christian sense or God in the Spinozan sense. I think the Spinozan sense is slightly stronger than the Christian sense, even though Badiou comes from cultural Christianity. He was the teacher of Zizek and so on. It is precisely the Stoic shoot-offs from Aristotle, which resulted in the early interpretations of Christianity, the Hellenic, Greek early church, which was really, all the way until Aquinas puts it into words, we're really sort of considering God as the first mover, the prime mover. This is important because in Meditation 5 and 6, we're talking we're drilling down on this first mover thing that is going to come up. So that's the new part of this lesson, which we didn't have last time. So meditation 3, it's important that Russell's paradox tells you language cannot totalize the multiple. And so we deploy the multiple without defining it. We deploy the multiple without defining it. What is the multiple? Well, one preliminary thing that we start off is a set. Set. Curly brackets, because every set has curly brackets. What is important is the axioms of set theory never tell you what a set is. And that's what Badiou is philosophically commenting on. It's because language cannot totalize the multiple that we cannot find a satisfying definition of a set. So we're going to use it without ever telling you what it is, because it is the thing that tells you what things are. So you can't say what that is. So that's why he takes set theory to be ontology, because if somebody asks the question, what is there in the world? What presents itself? What exists? Well, set theory is sort of the answer to that. And if you then ask the further question, what is set? Well, we just use it to give you an answer to the first question, right? Don't try us, right? The mathematicians take a physics approach and they shut up and calculate. Now, the fun part is that second question, what is a set? Does have a beginning. So usually when you do this childish thing where it's like, oh, but what came before that? What came before the universe started and so on? Then there's two things that you want. One is an explanation and the other is a beginning. And even though I can't give you a definition which would fit the explanation, I can give you a beginning. And that's the answer to the fourth meditation, which is what is the first multiple? What is the first multiple? Right? So I can't tell you what multiples or sets really are, define them, because I'm going to use them to define everything else, to show everything else that exists is, related in some way to other things that exist and so on. But the question of what is the first multiple does have an answer, and that is the empty set, the void. Void. Empty set. Let's use blue to make it seem slightly more important. All right. Any questions so far? Because this is the very fast recap of where we left off last time. And now we're going to go on to 5 and 6.
Sorry, can I ask you a question?
Yes.
Going back to the second meditations, can you give us another example of what is the structure, what is situation, what is consistent, inconsistent? Can you give the actual example?
Yes.
Yes, thank you.
Problem. Right. So the Badiou gives an example. Badiou gives this sort of example, which is kind of weird, but very French. During the French Revolution, so the French Revolution, let's do here. What was the French Revolution? It was this multiplicity of lootings, murders, philosophical investigations, organized militias, and so on. It was just an absolute mess, right? That is an unstructured model. Oops. Unstructured. Unstructured multiplicity. It is shit happening. Now, what is all of this stuff happening? Nothing really related until this. There was I forgot the name of the guy, a Christian patriarch of some sort. Imagine like the head of some local church. He comes out on the balcony and declares the French Revolution is over. Presumably in French. And I don't know the exact year because I'm not a historian, but I do remember the example that Badiou gives, right? So there was this guy with some sort of semblance of authority who comes out on the balcony. It doesn't matter who he is, but what matters is that the consciousness of the French people remembers this moment, right? It's in the history books, where he comes out and he declares the whole thing, the whole ordeal over. But think about how retroactive that is. There was no such thing as a whole thing. Right? There was just a bunch of stuff happening everywhere all at once that was unrelated up until that point. Until one agent, one subject, the priests, whatever, saw it as a unicity. There's a oneness, count as one. This guy was like, all of this stuff that was going on, it's done what it was doing, and nobody knew what it was doing until somebody recognized it as a unity, as a one, right? So beheadings and blood on the streets and so on. And one day, like presumably near the French Riviera, I don't know, somebody comes out there like, well, the French Revolution is over. Pretty much nobody was saying the French Revolution up until then. I mean, everybody wants to be the boss of the show. Everybody wants to be, the upcoming political head of the place where the new beginning, the renaissance of the countries, whatever is going to start over. There's internal struggles, and that was continuing while it was being declared over. Like, stuff is still happening. But what did happen when this statement came over is a count as one operation. The count as one operation structured this whole thing to be a structured multiplicity. Structured multiplicity. And that, in a historical sense, is good. In other senses, but you would say it's not so good, right? Because when a political party in France, like right now, they've got a bit of an issue with authoritarian parties, it's like slightly fascist. They lost an election just yesterday, I think, in Paris, right? They would make statements like the French people, they hate brocas, the French people who love croissants, these are totalizing statements because they're supposed to count as one everything which is a multiplicity of subjects in France, right? And that is an operation. It's not a real thing. There is no such thing as the French people, and there is no such thing as the French Revolution as a one. But it has been counted as one. That has been done. So there is the fact of the matter, the observation which Badiou says, which he does, is that everything which is presented has to have undergone some sort of count as one. Because if stuff was just happening and nobody did do a count as one, then it would remain unnoticed as a unity in such a sense. Like there would be no such thing as French people unless it had undergone a count as one. So this is a funny metaphysical example, but I say in class of metaphysics, why don't we say a table to refer to a table and a chair together? Because they always occur one next to the other, right? So why do we separate them as table and chair? It's a table, right? Why don't you just go to the store and when you pay like 160 pounds at IKEA, you get a table set instead of a set of tables and chairs? Well, it's a count as one operation, which I'm performing there. And you can do that for anything and everything, but it's not like you should. But whenever you find yourself seeing something as a oneness, as a unity, or appears in your mind, then you have done that. You inevitably have undergone some sort of count as one operation, and you believe it to be somewhat sensible. It's not like there's a oneness in the Platonic sense, like there's a oneness of all chairs, the perfect chair out there, and any other chair conforms to it. Because that would be ridiculous. Then table would be impossible, right? If there's a oneness of the chair and a oneness of the table, then where is my table, right? So set theory just unlocks all of these possibilities. So yeah, that was kind of it was a really good question, which is why I took time to explain it, because it's important. Especially meditation 2 is important because this structured and unstructured or situation or consistent and inconsistent multiplicity is what underpins how ontology is viewed by Badiou. Right, so how do we move on to meditations 5 and 6? Right, before we do that, we're going to go over here, and I'm going to recap what these things mean so that you can follow meditation 5's interpretation of the axioms of set theory, right? So there are axiomatic decisions which Badiou takes, like the one is not. And there's the actual official mathematical axioms of set theory, or the Zermelo-Franco version. So for you to be able to read them, you better be familiar with these symbols that we use. And I'm going to go over it. So on the screen, we've got in no particular order. So all of these are going to make an appearance in the next slide. This first, we're starting here. This first situation is A belongs to B, or because this one is small, like this one is a small letter, and that one is a capital letter. That was the small ones are elements, and the big ones are sets, and that's just the convention, right? So element A belongs to set B. Element A belongs to set B, and the important part is that in blue, that symbol there, that looks like a euro or something, means belongs, right? I'm sure that there might be some weird relation between, you know, the euro sign and the symbolization of belonging. The next one is curly brackets, which signifies set, right? Everything inside it, or that's just how we close off a set. Under it, so these are kind of weird. Here we have this U symbol, U-looking symbol. It is union, A union B. What does that mean? It is the set of elements in A or B or both. So when you get two sets and you do the union of them, then that basically gives you a huger set, which includes everything and anything from either, right? And now the next one is intersection. So A, intersection of B, is the set of elements in A and B. So both in A and B. So when you get the intersection, you get a smaller set, usually, of the parts or the elements which belong to both A and B. So the union doesn't care. If it's to both, it will just give you all of them. It will enumerate all of the elements of both sets, and the intersection gives you only the ones which are common to both. So this is sort of the Badiou would say that the intersection is somewhat totalizing, right? I only care about the things which I have in common with other people, like being white or being a man, like identities. But the union is about the transcendence of such identities, right? You don't care about the commonalities. You care about you don't care about the intersections. You care about union. So the next one here we have a statement. It says the set of all elements x, such that phi of x, the function holds. I think that's phi. I'm terrible at Greek. Petros, would you confirm that phi?
It is phi, yeah.
Yeah, brilliant. Okay, here we go. So what does that mean, right? This is just a statement that isolates what elements you're talking about. So let's say that phi of x was a function that said x is even. X is even. That's phi of x, right? Well, the set of all x such that x is even would be 2, 4, 6, 8, 10, and so on, right? All of the even integers, whatever. That's what the statement is. So this is a set because it starts and ends with a curly bracket. And inside it, there's a definition of what that set is, right? So we don't define what a set in general is, but any particular set can be defined through such a statement, like the set of evens or the set of odds or the set of sets which do not contain themselves and so on, right? Well, maybe not that last one, but the next one is this sign here. So again, I'll highlight in blue because it means exists. There exists backwards E means there exists an X which belongs to A, and that's the existence statement which I started when Russell's teapot. That's the thing which you're kind of careful about if you are a scientist, but if you're a mathematician, that's your bread and butter. Like you don't care, right? You can throw existence statements everywhere because you are trying to prove things ad absurdum. So if you said there exists something, turns out that something creates some sort of contradiction within the mathematics, then it doesn't actually exist, right? So there's a whole section later about proof by induction and proof ad absurdum later in Badiou, and he really gives these a solid treatment. But for now, we're restricting ourselves to meditations 5 and 6, which are the harder ones in section 1, and we need to know what this symbol is. It means there exists. And then we've got these logical operators. So these are logical symbols, and they are similar to the union and the intersection, the first two, but they're pointier because they operate on like elements, not on sets. Somebody has to fact check me on that. But the first one means and, the second one means or, and the last one means not. In the book, if you read the book, I think sometimes the not symbol is also written differently, like a squiggly line. So there's two options for what you can choose for not. But I think the squiggly line is the one that pertains to sets, and the not squiggly one is what pertains to elements, or but it doesn't really matter because the same sort of not. And then there's this last one here, means for all. So backwards E means there exists, and backward upside down A means for all. And that is a very interesting symbol because it doesn't discriminate whether for all means for every, or for any, or for all, right? Because I said it's important, whether you say anything on every or everything, totalizing stuff. Well, this symbol doesn't particularly mind because in set theory you sort of remain agnostic about, whether you're proving stuff for anything that comes up or for everything in total. And so these are sort of undecidable decisions that come up in different models of set theory. Or when we get to forcing with Cohen forcing, you'll understand sort of what that means. Okay, so now that we've got this out of the way, here's how we use the symbols to define the axioms of set theory. And this is a shorter list of axioms because not all of them are on here, but just the ones that we're talking about with Badiou. So we're engaging in a conversation with Badiou here. This is the Badiou reading group. We're not actually doing set theory, so that, you know, I'm assuming nobody is particularly like an actual mathematician, except maybe some of us. And these are the axioms which he particularly comments on. And that's what we're going to go after now. So, you know, like 40 minutes in, we are finished with the intro. But you know, that's how we roll. And let's begin with extensionality. So, axiom of extensionality. So the first one that we see is this statement here. So let's practice what we've read. For all A and for all B, where for all elements X, such that X belongs to A, and X belongs in B, there is a relation, which is the equal relation, between A and B. So this is this one here, actually I haven't defined, which is like if and only if X is both in A and in B, then A is B. So if all the elements which are in A are the same as the elements which are in B, then A and B are equal. That's sort of what this first axiom says. Two sets are equal if and only if they have the same elements. So that is, the word same here is important, so I'm going to write it down as well. Same. Okay. Axioms 2 and 3, Badiou puts them together. It's not like he puts them together like formally, but he talks about them as if they relate. I will explain why. The power set tells you that for all A, there exists the power set P. That for all B, where B is in the power set, B is a subset of A. So this one is also not defined. I haven't given you. But this one just says subset. And you know how this one is belonging? This one with the line under instead of inside, right? Because the line inside means you belong inside the thing. But if you're like under the thing, then you are a subset. Subset is, you know, you're a smaller part of the thing. You're not just belonging to the thing, but you can also be said to be a smaller part of it. So if and only if B is a subset of A, then B is included in the power set. That means that the power set is a set which exists. You can make it out of any given set, and it enumerates every subset of the given set. The power set is much huger in general than the given set. There's also a way that you can do it like this. If you have a set A and this is the number 2 to the power of 2, that gives you the power set of set A, because that's just like how many combinations of set A exist, and that's how many different subsets are going to go into the power set, right? Petros can fact check me on that, hopefully. The union set is the same thing, but sort of in the as above, then below. The union set just tells you that for all A, there exists set B for all elements X, where X is in B if and only if. Here we have just a moment. What is this? Right there. Such that there's a C, so there's another set introduced where X belongs to C and C belongs to A. Now this one is a little bit more annoying to read out loud, but what it really means is that you can, if you use a union on a set, then you can basically enumerate all of the elements. How do I? Right. Imagine there's a set. Imagine there's a set of stuff, and that set includes sets of sets. And I'm just gonna like pop in like a bunch of X here, X's here, you know, 1, 2, right? This is a set, includes sets of X1, sets of X2, and so on. The union here will actually just drop all of the brackets inside and just enumerate all of the elements. So you know how the power set puts a shitload of brackets inside? Sorry about the language, because it enumerates all of the subsets. Well, the union does the opposite. You know, it removes all the brackets and just gives you all of the elements by themselves. So then we've got the axiom of replacement, which is how do I say it? It's basically you can get a set out of a set if you just replace all of the elements in it with some other element. If you have a function which relates x and y in any way, right? So if I say for every odd number there's an even number, well, that's a relational. For every odd number there's an even number. Then you can create the set of one by that relation. So let's say you've only got the set of the even numbers like we did earlier. When I was showing you guys what this stuff means, the function, and you know the axiom of replacement, then as long as you know what odd numbers are, you can get the set of odd numbers as well out of the set of even numbers. That's what the replacement one does. And then the last one is the empty set, which we're going to center our discussion here. If you found the discussion of these 5 contracted, it's because we're going to focus on this one, because that's what Badiou focuses in meditation 5 and 6. So what does Badiou actually say about these? So Badiou, I'm going to read this straight from the book, says the axiom of extensionality fixes the regime of the same and the other. So remember how I said the same is an important word? It's because he sees the axiom of extensionality as the thing which differentiates between the same and the other. And that's an important thing for ontology, is how do you know what's the same and what's the other? Well, it's a regime governed by the axiom of extensionality in set theory. And for Badiou, any ontology, all the way from the Parmenides, from ancient Greece, has to have some sort of differentiator for the same and the other. There are things which make up an ontology, and Badiou shows that each and every one of those axioms corresponds to one of those things. That's why he said set theory is ontology. Well, it's because all of these things actually check all the tick marks which you need for an ontology. So you have the differentiating factor between the same and the other. He says the power set and the union set regulate internal compositions, subsets, and disseminations, union, such that they remain under the law of the count. Thus, nothing is encountered therein, neither lower down nor higher up, which would prove an obstacle to the uniformity of presentation as multiple, right? So he's paired the power set and the union set because he says they eliminate any obstacles to the presentation of multiple as such. That means, think of it this way. in science, you have reductionism. Reductionism is basically like if you say all the elements of the periodic table boil down to the number of protons in their nucleus. So you have subordinated the multiple of the periodic table with hundreds of elements, not hundreds, but 100 and something, to the one of the proton, right? You've reduced it. The opposite is true in Spinoza, where he says if you have the everything in the world is an instantiation of an affect. If you put all of those affects together, you have the infinite being of God. Then God is nature. He is the ceiling. So there is a floor and a ceiling to these ontologies. For Badiou, there is no such thing as a floor and a ceiling. Everything that goes up can go up into the multiple, and everything that goes down will only encounter the multiple, no unities. So for him, the power set is the axiom which says you can go as up as you want. You're just going to encounter sets of sets and sets. You can go as down as you want. You'll end up at a set. That's a multiple. So it's literally multiples all the way down, multiples all the way up. No ones. That's what he says. The axiom of separation, so that's the fourth one here on the list, subordinates the capacity of language to present multiples to the fact of there already being presentation. So subordinates the capacity of language to present multiples to the fact that they're already being a presentation. It is the fact that if you are already in existence, if you already exist, if you're already in the being of the multiple, then from inside it, you can separate it however you want. I can say Chable, right? My dream is to say Chable and to be valid, right? Because I've separated out into existence this I've got a count as one which defines a Chable very rigorously, right? Nobody can come up to me and be like, well, your definition of a Chable is contradictory because no, right? I can just define the thing, and I have separated out from existence a one which is now part of my ontology, right? Chables are part of my ontology. Unfortunately, I have a very rich ontology, but Badiou has a rich ontology, which slims down later. Don't worry, he doesn't want Chables to be, like an important thing, part of it. But the axiom of separation just tells you as long as you're within the situation, then you can sort of like divide it up however you want into counts as one. And that's a good thing because language is very successful at referring at stuff or referring of stuff. And the point of failure is what he talks about a lot, right? Because why does language fail to totalize the multiple? Well, we're gonna find that out. That leads me perfectly onto the empty set because that's sort of precisely where the language fails. And with that, I'd like to lead with Badiou himself. I'm going to share my screen, a little video of him explaining something. And I'm hoping that people can hear it. I'm sure that they will be able to see it, but I'm not sure if they'll be able to hear it. So let's share the screen. Can I do that? Share. I need to request from Oliver. Hopefully he's there too. Share. And let me know if you can see Badiou in glorious 360 pixels. Can I get a yay?
Yeah, can see it.
Yeah.
Okay. We're here. We're on YouTube. We're with Badiou. He's giving a lecture. He's live kicking, not live, but alive. Here we go. Do you hear him? Do you hear his French accent?
No, can't hear that. Sorry.
It's a bit buggy.
Unlucky. Okay, let me have a quick look again if that's fixable.
Could you leave it playing in case it
Share sound. I got it.
Oh, you got it. Great.
It's an obligation.
Yeah, we can hear it now.
We begin by
Okay, I'll let him speak for himself.
void.
Sorry, I'm gonna
We
move it
begin
back.
by giving a name to the
Giving a
void.
name. That's important.
So we have a name, and after that, we take this name as the only element of a set. So we use the third possibility. So this is the result of possibility 1 and 2, so the result of the possibility 3. So we have used all our possibilities. Alors, this sort of thing, which is the name of the void as the only element of a set, it's a singleton. The technical name. Singleton is the name of a set which has only one element. And when we do that, we create this singleton, and we can give a name to this creation with the first possibility, and the name is precisely 1.
All right, there we go. I'm gonna interrupt him there because you know he's made his point. He talks about 3 possibilities. Possibility 1 is to separate being however you want, so that's sort of the brackets or the ability to count as 1 and multiple. The possibility 2 of throwing stuff into that box or taking it out, which is what we did here by. I don't know if you guys can also see the board at the same time. Do you see the board?
You mean your board?
Yeah, the whiteboard.
It's very small. If you could maybe go back to that screen, I think that would help. As in minimize YouTube or share the board screen.
Yeah, let's try that. Any improvement?
No, it's still on your name, but it's not on the screen. Maybe if you...
It's because you're not sharing your screen, so if you stop sharing it, and then it will go back to the thing you had on before, probably.
Yeah.
Yes. Yes, just a moment.
Oh, here you go. If I do stop like that, there you go. I think you're back now.
No, not quite the screen that I want actually, because it's. Just give me a second. Sorry that I'm taking up the time. Here's the room. Okay, can you guys see this?
We can see the axioms of set theory.
Yeah, brilliant. Okay, so erase that. So the second possibility is you can take stuff into. You can throw them in this arrow here. I threw in some elements into this separation of existence that I created, these curly brackets. And I can also do the opposite, which is take it out. If I take it out, there will be nothing here in this set. Boom, I can take it out. No need for these brackets because now there is no x1. You know, I can take out x2. I can just do that just because that's a possibility. And oh my God, this one is empty. So this one's gone empty. Yes, we're going to be finished in 2 minutes, 2 to 5 minutes. And the empty set is something that we can use possibility 3 on, which is to give something a name. We can name it the empty set. So I've just used these 3 possibilities, and I can just reuse them. I can say, okay, what is the set containing the empty set? Well, it exists, it's there. I'm going to give it a name. Turns out that name is 1. And then I power set this one. I go, what is the name of the empty set of the set containing the name of the voids, and then the set containing the name of the void. So there's a set, an element in that set, which is inside a set with another element. Well, that's 2. And I can keep going, but that will be, it will get repetitive. Why is this important? Right. I'm going to read out a few more quotes just so we can actually finish up, and then we can go, because Birkbeck is closing and you guys are probably tired already. A multiple of nothing has no conceivable differentiating factor or mark. The unrepresentable is inextensible and therefore indifferent. The result is that the inscription of this indifferent will be necessarily negative, because no possibility, no multiple can indicate that it is on its basis that existence is affirmed. Right? What does that mean? There is no multiplicity inside of existence which can claim it is because of me or because of you or because of said multiplicity that existence is therefore existing. If you ask why is there something rather than nothing, we're going to add this question. Why is there something rather than thing? I cannot immediately give an answer to that question, but I can tell you that no multiple can give you an answer to it either. No multiple can take responsibility for that question, for the answer of that question. But we have a name for that. We have a name for the set out of which every multiple is taken. It's the empty set. And there's something about the empty set. It's called, it's very important. Just one moment. So I get this right. I don't want to get this wrong. Vacuous truth. Okay, vacuous truth. Property. Vacuous truth. So the empty set has this property. It's called vacuous truth in set theory and mathematics. And that means any universal statement about elements of the empty set is true. That's a very interesting thing. What does that mean? It is, if I said all the elements of the empty set are purple, that's true. All the elements of the empty set exist, that's true. All the elements of the empty set love Badiou and read him regularly, that's also true, because there is no elements. There's no elements, it's vacuous. And so anything that I can come up with, some universal truth about what's inside it, is in fact vacuously true. And I will leave you with this. If you go from this is something which the empty set does. Indifference. Indifference means the empty set has no differentiating factor from anything else or from itself. What there exists is difference in itself for Badiou, right? Because every set, by the axiom of extensionality, is only different from another set if there is some element of difference in it. But the empty set does not have any elements, and so it cannot differentiate itself. And in that sense, it is indifferent to all positive differences that you could ascribe to it. And it is an existence which permeates every set. If I said that there's a set of numbers like 1, 2, 3, or students, me, somebody else, or buildings, building 1, building 2, doesn't matter. This set is permeated by the empty set because it exists in every set. It's always there. You know, you can say every set includes it because it's empty, so nothing stops it from being inside every set. And for Badiou, that's actually a mark on ontology itself, that there is something unrepresentable, mark of unrepresentable on ontology. He does this etymological treatment, which is very funny. He says, look, the mathematicians, they were trying to come up with a symbol for the name of the proper name of being, the void. And they didn't use a Greek letter like they want to, or some other symbol that they knew of. They used this like forgotten language, some Scandinavian, old letter, which is foreign to everything else, because it is supposed to name something unrepresentable in every being, something vacuous, and that's why they came up with this symbol. And he draws a parallel between the bar, the Lacanian bar, I'll leave that for homework because I don't have time. But that's something that Badiou says. It's not like the mathematicians knew about it, but it's fun to think about them knowing about it. There's a barred existence of inexistence, right? You can talk about nothing in and for itself as long as it's not for itself or for any other. It's not for any other because it's indifferent. It's indifferent. And one thing to remember, if you come out of this session with like one important statement, it's that for Badiou, pretty much all statements related to the one God, unity of being, university, and so on, are vacuously true of the empty set. For Badiou, pretty much all of the arguments as the prime unmoved mover of all things, the result of physics and so on, God turns out to be true of nothingness itself, right? And what is important is that nothingness, yeah, it's all powerful, all knowing. Hi, we're finishing in 1 second. Give us 1 minute. And
No,
sorry,
I thought you
just
were going to say there, I've been authorized, I can stay to 10 or something.
But
I mean, look,
we technically our booking is until 9, and I know that I'm running like a bit.
all right, just a couple more. I'll leave you to the very last minute. So I've got another floor of Fieras. So you probably get another 5 minutes.
Thank you. We're a small package, so we'll be out right away.
Okay, as I said, I'll be back in about 5 minutes.
Thank you.
Okay, thank you.
So yeah, I'm finishing. So this is like the, all powerful, all knowing. They're vacuously true of the empty set. But the empty set is importantly indifferent. For Badiou, God exists, but he doesn't care, right? That's not true. Badiou absolutely opposes the existence of God. He says the one is not. But what's important for his ontology is that this prime mover, this first multiplicity, is the empty set. It takes on all of the responsibilities for which theologians and philosophers give to God, but turns out that the empty set can take on all of them and wouldn't care, right? It can bear that weight, that sort of ontological weight of getting everything to all of a sudden start, to become being, to exist. So this is the suture. The empty set contained within every set. Within every situation, there's an empty set as the mark of the unrepresentable in that situation. That's the suture between being and representation. And the empty set bears on that weight of being the proper name of being the first multiple. And that's where we leave off in meditation 6. Meditation 6, Aristotle is very important in there, and motion. Motion is this paradox, Zeno's paradox. Why can anything move? If everything is a substance, then no motion is possible. Well, because the empty set is part of any situation, right? That's the funny answer that Badiou gives. It's there in meditation 6. I hope you guys enjoy reading it, and we'll finish here. If you have any questions, please leave them in the chat, because we are being kicked out.
Thank you.
You're welcome.
Thank you.
The slides will be available. They probably won't be available, but I'll do my best to allow people to have some notes for later. All right. See you guys next time.
Great. Thanks so much.
Bye-bye.